So to get started cutting out the plans, you're going to want a straight edge to help you line up the lines between the different pieces of paper. You're obviously going to want some tape so that you can tape each piece of paper together. You're going to want your foam board. You're probably going to want some scissors, although these aren't necessary. This is just useful for cutting around the perimeter, maybe cutting out parts and rearranging them, stuff like that. And of course, you're going to want yourself some sort of X-Acto or razor blade. The sharper the blade, the better. If you can, use new blades, because dull blades are not fun to deal with. When you go to cut, they'll tear the paper and they'll bunch up the foam, and you'll get much better results if you just use sharp blades. So I've trimmed around the edge here and then just taped it down to the foam. So now we can start making our cuts here. If you print them in color instead of black and white like I did, then you'll have the score cuts marked, but for this, I'm just going to remember where the score cuts are. So for example, all these are score cuts, and then just the perimeter around the side and these little pockets that we have to get out are where we cut all the way through. And we'll just repeat this process for the other sheets. Getting the pitot tube installed in the nose cone here. There's a good bit of clearancing and stuff I had to do to get this to fit. And you'll notice it's actually angled down a little bit, so maybe we get some better airspeed readings at a bit higher of an angle of attack than what you would usually. Here's a former for the next part of the fuselage. Other small stuff to watch out for is just misalignment of parts. So when I bring this part down here, it doesn't quite want to line up on the edge here. So when you assemble it, you've got to make sure you sort of push it and pull it so that everything lines up. Because when you cut out these plans, unless you have it done by a laser cutter, you're probably not going to get super high precision. And so there's going to be some sort of wiggle and misalignment and twist in your parts, and you're just going to have to deal with that as you assemble it. Another thing you may have to do at times is sort of tapering or trimming formers to get them to fit. This is because we built this former based on the plane that was defined here, and then the actual former extends here and here. So if the part's smaller on this side, the former's gonna spread it wider than it actually should be. So adding that little bit of taper there helps to alleviate that. Now for joints between two fuselage sections like this, the foam to foam gap is done by the glue, whereas the paper to paper gap is usually done by tape. So if you just add a little bit of tape on each of these seams, it'll give it a bit more strength than it otherwise would, because you'll be able to take the tension forces in the paper across that joint. I'm not going to have access to these connectors here, so I'm just putting a bit of glue on to make sure they don't back out. Although this is going to be enclosed by that former that wraps around the top here. So this right here is our GPS module. This is going to go just down in the bottom here. I like to get this as forward in the plane as possible, because that's usually the place where it's free from most of the electrical interference or any magnetic stuff that's near that. Although I guess now that we are putting a magnet in the hatch there, it might get thrown a bit, but that is what calibration is for, so we'll get that glued in. I think right here I definitely could have used an extra 3/16 on the border of this part just to clean up this gap here. I think it should work out fine, because you're not going to see this. It's going to be covered by the hatch anyways, so. To be honest, that doesn't look half bad. As you attach different fuselage pieces together, you just want to occasionally sight down the entire fuselage and make sure that they're all lining up decent. You can adjust as needed. And when you're taping these joints too, if you can pull them tight a little bit. And that'll just pre-tension the joint and help resist stretches. It'll suck everything together. Here's how the nose wheel is going to be supported. We've got the nose wheel assembly, and we've got these 2 plates of foam, and each one of these has a servo horn, circular servo horn on it, and that just keeps the wire here from going through either side. And then that distributes the load into the foam, which goes into the rest of the aircraft. One thing you can do if you want something to have a good connection to the foam is just cut out the actual paper and then attach directly to the foam. And that'll give you a bit more of a stronger, more direct connection. We want to make sure that this is in here pretty good, because this is what's going to be taking all of the landing gear loads, basically. Alright, so I've gotten most of the vertical backlash out of this nose gear here, and I'm adjusting that plate so that it sits how I want it, and I'm going to glue it in. This one's a bit less critical since it's only keeping the nose gear from falling out of the aircraft and providing the horizontal and front and back positioning. The bottom one will take most of the impact load on landing. It's always good to have a scrap piece of foam around so that you can get excess glue out of places that you can't reach. One of the things I'm doing in these real tight radii here is I'm actually cutting the foam in half so that it bends easier just in that real tight radius. So now this should go like this. One of the biggest things that can help the durability and quality of your aircraft is just going slow and taking your time, because the longer you let the glue set without moving it around, the stronger the joint will be. And the more time you take, the more likely you are to catch mistakes, the more little things you can do to just help the aircraft be more durable in the long run. Like hot glue hinges, for example. Later, we're going to put some barbecue skewers in the leading and trailing edges of the control surfaces. Just small stuff like that. Adding some popsicle sticks to the bottom of the battery tray here. These are just to give it a bit more strength, and when we go and put these straps on here, to prevent them from pulling out. It's going to be a tight squeeze in there, that's for sure. Another beneficial thing to do to battery trays is just to put a bunch of glue on here and then smear it all out. That'll increase the coefficient of friction between the battery and the surface here. Help it stick better. I got the straps and the battery in the place I liked it, so I glued it down, and then I also added these extra reinforcements here just to keep the battery tray a bit more sturdy on the bottom of the airplane there. Nose wheel steering servo going in. So here you can see that slot design I was talking about. So this nose gear wire is just captured in there, and then goes from side to side just like that. wrapping your servo extensions in tape like this, maybe putting a little dab of glue in there too. That's a good insurance policy just to make sure that those don't come out in flight. Looks good. We're just going to add some pieces of paper on here to make sure that these don't get packed full of landing gear, junk, and grass and stuff. So battery tray looks like it's in. If you've got back-to-back formers that are going to be glued to each other like this, typically it's a good idea just to peel off the paper from both sides so that you're getting a direct connection from the foam to the foam instead of the foam to the paper, which is weak, and then from the paper to the paper through the glue, and then from the paper to the foam. So you're reducing the load path and reducing the dependence on the adherence of the paper to the foam. When you're doing curved skins like this, you peel the paper off one side. You want to try and get it as much as you can, but this black foam board here, the paper on it tends to rip a lot, and so it's hard to get most of it off. But this piece I got pretty good. And then what you do is you take it, and you could either form it in your hands, or I like to use the edge of a table like this. Usually this is a two-hand operation, but I'm filming, so. But anyways, you just keep doing that, and you're compressing the underside of the foam so that it'll tend to take its shape. And while you're doing this, try not to bend it back the other way, or else you'll start to get creases in it. And additionally, for tapered parts, like this isn't highly tapered, but maybe for something like this, where maybe it's a section of a cone or something, you could take this, and then as you're rocking it, you could sort of change the distance that each end goes through. So this one I would go more like this. And you can see how this point over here is staying pretty much fixed, whereas this one is moving a lot. So you can see on this part, we're going to have to take this stuff right here off by beveling it. Usually I like to do this after the fact because then you can trim it pretty much exactly flush, instead of trying to guess beforehand. So now this thing should sit relatively flat. Still a little bit up here it looks like that needs to come off. That looks pretty good. So now the next part we just glue on. We can actually take this over to where we're trying to fit it to and make sure that it all lines up. But if it didn't, you could tweak it one way or the other just to make sure. Essentially what we would be doing there is we would be using the existing part as a template. Got a magnet installed up front and this little tab in the back. On the fuselage side I got a magnet up front, The tab goes right there, and then I've got these little tabs just to keep the middle splayed out a little bit there. So back end goes in like this, front end comes down, then these two bits pop these out a little bit to the side, and it fits pretty good on there. It's not perfect, but it's good enough, that's for sure. Now this right here is a good way to drastically improve the look and durability of your control surfaces. Basically, you just get probably about 3/8 to 1/2 of an inch on the end here, and you take your barbecue skewer and you make a little notch in here, just so it sits a bit further in. And then you take it, and you measure, and you cut, and then you can just tack it in place with a little bit of glue. And then for the big glue up, you put some on this guy, and then just fold it over and hold it there. Looks super, super clean. Check that out. And so I'm going to do that to the canards here and the rest of the vertical stabilizer. So for the canards, it's just going to be control horns embedded into the side of the foam here. And then on this side, I'm going to have one of these just glued onto there. And then there's going to be some sort of bend in the wire there and some sort of linkage going to these servos. So, and then to attach to the canard, this wire is just going to have some sort of bend in it, and I'll cut a slot in the bottom of the canard and then glue the canard down on top of it. Well, it was more than a bit tedious to get that wire in there. I had to do it in situ, so I put the wire through and then bent it on the inside and the outside. It took a good bit of kerfufflery to get that stuff to all work out, but it looks good and it moves nice, so next step is to get the canards on. This joint between the wing skin and the spar here is going to be a main structural joint, so I'm going to make sure to get a good bit of glue on it. It's also a good idea around any joints between spars to get a good bit of glue in there as well. And that'll just tie the whole structure together. I'm starting to realize that these style of fold-over formers might not be the best, because when you have this extra bit of paper for the C-fold going around, basically if you don't make sure to glue this piece of paper to that foam there, then whatever you glue this to won't actually have a grip on the foam here. It'll just have a grip on the paper. So I'm going to cut these off of this for now, and I don't think I'll be using that style going into the future. This is going to be the former that mounts to the EDF, so I want to make sure it's in there real good. Now right here is some of that thrust tube clearancing we're going to have to do to fit the spars in there. And I got a bell mouth on here that's been clearanced to fit the spar and the rest of the fuselage. I got some landing gear bent up. I'm going to glue these in real quick. So I got those landing gear installed, and what's more, I'm starting to work on the thrust vectoring here. So I've got the yaw servo and its control wire in, and I'm just looking for a good place to put the pitch servo, because it's going to be sort of under the Razorback here, and I need to make sure that I have enough space in there. And these long push rods, what I'm going to end up doing with these is putting some zip ties along the length, and then putting them either into the thrust tube or into the base plate here, just to keep these from wiggling around like this. That'll just give the controls less sloppiness and more rigidity. I had a good look at the cab model, and there's not really a good place to put that servo where it would be hidden well, so I think I'm just going to put it on the other side of where the rudder servo ends up being, and then I'll just run a linkage external to the aircraft. Looking good. It's always a bit chaotic when you're doing big glue ups like this, critical glue ups like this. Worked exactly as I wanted. Just make sure it's clocked correctly. Yeah, that looks pretty good. So I got the wing servos in here, so that means it's time to bevel and then finally close out these wings. Now beveling requires a nice sharp blade, and if you can, get something that's a bit longer than your standard X-Acto blade, because it'll make it a bit easier as well. It takes a little practice, but you should be able to get a decent bevel. Just like this. And there we go. If at any point the foam starts to bunch up or the paper starts to rip instead of cutting, you need to go back and sharpen your blade. I think I might have gotten through the paper layer there, we'll see. Oh, it looks like I just missed it. Alright. Let's flip this back over. And this guy is going to fold right over. I'm going to have to poke a little spot for my servo control horn, wherever it may be. There it is. This glue up here is going to be a fun one. We've got a lot of stuff to glue. We're going to do the leading edge here, this sort of wingtip area, all along the trailing edge, and of course on top of the ribs, and the servo as well. Time is of the essence here, because this glue is going to start cooling off the moment you put it down. It doesn't mean rush, but that means you got to do it relatively quick. So do a few test runs, dry runs if you need to, before you commit. We're going to keep good pressure on the trailing edge, because that's going to be where, that's going to be the main joint that we want to close here, along with the rib furthest to the side. You want to keep those closed. As long as those are closed, you're good. Trailing edge here looks like I could use just a little bit more, so I'm going to chuck that in. While we're here, we can also put a bit more in this wingtip. I got the main gear wheel pants on here. They were pretty much the same process as the nose gear, just you got a front piece and a back piece, and then you stick them on. I got this little intake lip done here, as well as boxing in the wheels. I've got the barbecue skewers in along the elevons and the leading edge here. And I've got the Elevon hinges cut out and hot glue reinforced. I'm starting to get this piece fitted in here, and I'm noticing that it's sort of hard to make some of these tabs line up. And I think that's because these tabs here are reference to the wing, and then this is also reference to the wing, but this is reference to the bottom surface instead of the top surface. And so if you misfold this wing or it's slightly out of alignment, that stacks up into the placement of these tabs. So I've just cut the back ones off. Also, part of this is I was planning to slide the wings in from the side, but obviously I built the wings together as one thing. So there's sort of some order operations stuff that I messed up here. So I cut off the back two tabs. Then I was doing some test fits with the other part of the fuselage up here at the front, and then these gaps sort of between here and the side of the fuselage here weren't closing too good. So what I think I'll end up doing is probably just making this seam the best it can, and then I'm just gonna like cover it with some I think like a strip of black material would look good, either like some electrical tape, or I could cut out a strip of foam board that's like a 45 with the paper on the 45, and then just put that along there. Alright, so I'm gonna have to get glue all along the bottom here. I could probably just do that on here. And then we could save this seam for after because there'll be a bit of a gap there anyways. And then we've got to get here around the fan and here on the side. Except we don't want to go too much because we still got to get this top piece on. So, oh, and we also probably want to get on the side of the landing gear plate here just so that we can reinforce that area. Think about this, think about what I'm doing before I do it. Alright, I think I've thought about it enough. So we can start. And then side of the landing gear plate. That's real good. And then all along here. Alright, here goes. Let's come down like that. Looking good, looking good, looking good. Get that in there. Get that there. Make sure this is all the way down, which it is. Square that up. Very cool. Now we'll just hold that in place for a bit. And you can see here what I was saying about the seam. It's a bit open here, and then these tabs don't quite line up. Alright, so next we can get the top on here and this next side. Go, go, go. Come on. Get down in there. Yep. Get it to the back. Looks good. The front needs to slide over. Okay. This piece is just about in there. Make sure this top plate is level. About as level as it can get. It's a bit twisted right now. Those are all parallel with the back. It's looking good. That fan sits in there nice. If you ever get hot glue on the paper of the foam like this, you can just use your fingernail or just the skin of your finger, and if you go back and forth enough times, eventually it'll come off. But the important thing to do with that is just to let the glue get sufficiently cooled down before you start doing that. Because if it isn't, then you'll just basically just glue it all over the area, and it won't look good. So I think I'm actually going to put some beads on the inside here just to really lock this thing in. So now we're going to get that bead of glue along the sides and put a bit down here for that landing gear side plate. Good to have a scrap piece of foam with you for this stuff. Alright, the test fit worked out pretty good, so I'm going to go ahead and get this guy in there. Alright, this is going to be the big one here. We got two halves of the aircraft to join. I've taped this duct door down here so that it doesn't get in the way while we're doing this. I'm going to put it together like this and then double check and make sure that that door is in alignment. And then we'll go for it. Yeah, it's looking pretty good there. Houston, we are go for glue up. Come on. Come on. Maybe it would have been better to tape it up on some parts and then glue it, and then undo the tape and then glue it up on other parts. Because this is not working too good. Alright, let's get the tape out. Where's the tape? 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 It's under there, isn't it? Yep. Okay. Okay, that's good. Top side. Flip it back under. Alright. Let's see if we can salvage this a little bit. Oh yeah. Get a ton of glue in there. More along here. More along here. More along here. Let's go. Want to make sure the fuselage is on reasonably straight. Yeah, it could be twisted a bit this way though. Double check this. Yep, lines up good. Sight down it, make sure it's not like bent or anything. Yeah, it needs to be like this. Alright, I'm gonna get some tape over this. Bring that up. Let's see how twisted or not it is. Yeah, it's not too bad. It's like maybe a degree or two. That'll be alright. There's tons of weird twists, and this fuselage is like slightly banana shaped. It's got a bit of a dog leg in it. But you're not gonna notice that. Well, now you will that I told you, and I'll show you, but if we just keep it a secret, nobody else will know. Especially with these like really complex geometry things, the chances of you doing everything perfectly right and it coming out perfectly symmetrical, especially if you're like just doing it from paper plans, is pretty close to zero. So you just gotta correct for it as you build. And there's gonna be parts where it doesn't quite line up like this, and you just gotta deal with it. Alright, let's flip it back over. And let's get this joint here reinforced a bit. Here you could also see what I said about that leading edge not lining up. It's just too far out on each side. I think the tabs actually line up pretty good. I mean, that one's maybe like a 16th or an 1/8 off. But I think just these two wings somehow got bowed out. Like maybe I didn't do the cuts that joined them together perfectly straight, and so they got sort of out like that at the front here. One thing I should have done probably when assembling the wings like this is to measure between these 2 points and make sure that dimension was correct. Because what I did is I assumed basically that both of the joining surface between the wings is back here, so I assume that both of those are parallel and the angles and stuff worked out, but obviously that wasn't the case. So we'll just fill that gap with glue just so the 2 parts are joined, and then we'll go over it with something a bit more aesthetically pleasing later. Now, because we can, I'm actually going to get these joints from the inside. And then hopefully this door should close. Yep, it's perfectly in alignment. That's good. I also forgot at the back here, we've got these little tabs to glue in. Now, just for a little bit of extra reinforcement, I'm going to take some of these spare carbon fiber tubes I had and just glue them on the inside of the intake. I'm going to put them on the top side because that's where all the tensile forces are going to be. Figure it can't hurt. It's a couple extra grams and potentially a lot more strength. So the tricky part here is going to be not to get glue on my hands and burn myself. Gotta very carefully get that guy in there. And these are out of the way of anything else that would be important. So they're not going to interfere with the door, the linkage for it, or anything else. So now we can start getting some of the electronics in here. This is the sort of layout we're going to go with. We're going to have the flight controller right here. I'm going to have to cut a pocket in there so that it can nest down and get some cooling airflow on its heatsink there from the intake duct. And then this will go back to the fan there. And then we just got to do all the wiring and stuff to get this to work. I think I might actually build a platform for this thing to sit up a little bit so that the power wires can run underneath better. And then also we're going to have a hatch so that we can access this thing if we need to. Specifically this here micro SD card for the data logs, and the USB here so that we can program it and do all the configuration stuff. So we'll get that in first. And of course it's not going to be so simple because we've also got formers here to worry about. So we got a former that's got to go there and one that's got to go there. I think that should be sufficient to hold it in. That's starting to look like something there. Now I just got to think about, I got 3 more servos that I need to get through here. So we've got the 2 in the back, one for the rudder and one for the pitch thrust vectoring. And then we've got to find a good space for the door actuator servo. I don't think that there's going to be any space for it underneath here, so I think we're actually just going to have to put it inside the intake duct, which isn't optimal, but it's going to save us a lot of headache trying to squeeze something in here somewhere. I guess that means that we can start trying to get the first Razorback piece down here, as well as the vertical stabilizer put in, and those two servos, one for the rudder and one for the pitch thrust vectoring. Alright, here's sort of an idea for the Razorback piece. This is about the best I could do to get these servos to fit and not poke out the side there. And then this whole piece is just going to go somewhat like that. And then we're going to have to clearance the vertical stabilizer here. And unfortunately, most of this, actually pretty much all of this down here, isn't going to be able to contact the thrust tube because of the motor wires here. So it's just going to be supported in the back there and then by using this piece. But it should still be sturdy enough. We'll be able to get a good amount of glue in there. First, I'm going to get this piece glued in and these servos glued in. And then for this part, we're going to have to clearance this former a little bit. More than it already is, just to be able to get these wires through. Try and get this in there. Get it in the back. Get those lined up. Come on. Get on this side. Needs to go down more on this side. A lot more down on this side. Get those in. Come on. All right. Back's sitting down good, and looks like the front's sitting down good. So we should be good to glue this guy down. There it goes. In you go. Alright. It's on there reasonably stout and reasonably straight. I think I need to glue around the servos a bit more. That'll give it more support. It's almost starting to look like an airplane now, eh? Here's the linkage solution I settled on for the Canard Servos. I made a few of these, which is just an old control horn that I fed some wire through like this and then super glued it in place. Basically, that just makes this control horn rigid with the rest of the wire. And then this hole is pretty much the perfect diameter for the wire that I used in here. So it just goes on over the end there, and then you attach the linkage to the servo. Bit of a tight squeeze in here, but the battery does fit. Alright, I got the linkage set up on the door here, and I've got the servo installed with a bit of aerodynamics around it. Just some fairing on the front end back here. And I've also got a little bit of stuff going around on the fan here to hopefully direct airflow in there a bit smoother. Just to help the bow mouth out a little bit, get rid of some of the dead air pockets around the fan there. What we're going to do is we're going to take this door, we're going to take this wire, send it down through that little gap there, and then on the top side there, we're just going to bend the wire into the servo, and then that'll complete the linkage. I have the servo in the full up position right now, and so I'm going to bring the door to the full up position. I've already measured, so I know I have enough stroke length to get it to go all the way back down, but it should be good here. So we're just going to take it and bend it. Watch your eyes. Safety squints engaged. There we go. There we go. Alright, and then that end bit, we just need to bend that upwards. And there we go. It's all set up. Guess what time it is? It's cable management time. The last thing we got to think about before we close this whole area up here is where we're going to put the receiver, because we've got sort of a limited space to work with here. Now, the fan's right back here, the ESC's here, the flight controller's here, and the battery's here. So, like, none of this space here is, like, good for the antenna because there's plenty of stuff to cause electrical interference. So, I mean, basically anywhere along this axis is not going to be good. I could put, like, the receiver up here somehow and then have the antenna come up here. But, I mean, even here, there's still, like, a good bit of metal from the Canards and stuff. So, I don't think that's a viable option. Anywhere back here isn't good. Anywhere just in general along this is not good because you've got power from the battery running here all the way to the back, and there's ESC wiring and stuff here. So I think what we're going to have to do actually is get this antenna like out the side somehow. So I think maybe this will go down like into this little space underneath here. The receiver will sit down in there, and then we can route the antenna like out the side of the intake here and then like into the wing or something. So I decided to put the receiver in the wing here. The antenna is like coming this way, so hopefully it's far enough away from all these electronics and the carbon fiber in the wing that we get some good reception. Alright, a test fit of the Razorback looks pretty good. I cut a little hatch here so I could access the SD card and the micro SD right there for the flight controller. So I'll go ahead and get this thing in. So those hatch pieces went on pretty nice. I also installed some black stripping around the winged fuselage joint here just to hide my sins a little bit. I've also got all the linkages in for the Elevons here and the rudder. And so all the controls are functional. I did actually strip out the door servo because the just dynamic pressure of all that airflow going through the fan is so great that it actually tries to suck the door up. So I'm going to see if I can find a Metal Gear servo for that one. All the other ones are Metal Gear, but I ran out of Metal Gear servos, so I'm going to have to... I don't have any good Metal Gear servos. I mean, I have ones that are good mechanically, but they don't have any good electronics in them. So I think if I transplant the electronics from this one into a dead Metal Gear servo, I'll be able to get a good working servo that I can put in there that won't strip out. Got the new door servo in. It's all buttoned up, all functional, all ready to go. Just a few things we're missing. Alright, weight and balance time. I've got the battery in, and we should have the CG approximately on this parting seam here between these two formers. So we're looking pretty much right on that. We are looking at a hefty 1,848 grams. This thing is real heavy. So that increase in weight puts our wing cube loading at around 20, which is a lot higher than I wanted it to be. But I guess we're just going to have to wait and see how this thing flies. If we had done the 4S version, I think it would have came out closer to that 4S version that we originally spec'd. There's a lot of added weight here in terms of the battery and the motor, but I think it should fly good. It'll just be a question of how fast this thing ends up landing and so forth. So. I think it's got some pep, that's for sure. Alright, this one's going to be with the door open. See the thrust vectoring going on there. Thing definitely has some get up and go. We'll have to see what the thrust to weight ratio is on the logs there, but looking at the log file here with the door closed, we're pulling about 1200 watts and we're pulling about 0.75 G. It's looking pretty good, although I do have to check and make sure that my throttle is set correctly, because you can see the throttle here is only at 89%. So I'm not sure what the ESC is calibrated to, but I'm going to have to see if there's a little bit more headroom there. So that definitely sounds a lot higher pitched. So there definitely was some extra thrust that we were missing there. So we can see now with the throttle at 100%, we're pulling about 1700 watts. And then this is with the door closed here, pulling about 1 G. Not as many G's on this pull. Actually, I can't remember if I did, if this was door open or if that was door open. But anyways, we're maxing out pretty much around a bit less than 1 thrust to weight, around 0.9, and we're pulling around 1700 watts, so that's pretty good. And so if we take that 0.95 as our thrust to weight and then multiply that by the weight, which is 1850, so that means we're producing around 1750 grams of thrust, which is not as much as this fan setup is rated for. I think static it's supposed to do like 2200. It is pulling the right amount of current, but I think there's just a lot of ducting loss. Even when we have the door open, it's not the most optimal intake ducting configuration. That inlet lip is a little small. And then also you're talking about the thrust tube, so that's additional losses. And my little TVC nozzle there, it's below 100% FSA, so you lose some thrust there, which means we will get a bit more speed than having 100% FSA, but I think it's around 90%. But there's also the sort of lip where it goes from the static part of the nozzle, and then it expands out a little to the moving part of the nozzle, which it has to do for geometric reasons and making that work. So overall, I wish the thrust to weight could have been a little bit higher. I wish the plane could have been a little bit lighter, but it's the highest thrust to weight I've had on a ducted fan before, so it should have some pretty great performance in the air. Well, I think this is a good place to leave it, because the only thing left we have to do is to fly this thing.